Okay, hi everyone. We're going to start our chapter 5 here, part of chapter 5, and it's about special distributions. Now you have done for your discrete random variables, okay? You still remember you did your discrete random variables in chapter 4, and you also have another type of random variables that is continuous random variables. So if you still remember, discrete random variables will take exact values, that is, for example, 1, 2, 3, and so on, which means you don't have any fractions or decimal numbers here. But continuous will take something in between. Okay, you may have 2.5. Okay, you may have 1 over 2, right? So in this case, you're looking at continuous random variables, which you're looking at continuity of values. Okay, for under discrete, looking at binomial firstly, and then later on we're going to Poisson distribution. Okay, so basically you're having two types of distributions for discrete random variables. So please take note, first part here will be of your discrete random variables. Of course, second part you will be doing normal distribution. This is specifically for continuous random variables. Okay, so you need to know about the properties involved in the binomial and Poisson distributions, and also later on for our normal distribution you will need to use the standard normal distribution. So if you still remember, this is your z, means it's referring to your z-score. Okay, this is especially for those who have done your normal distribution previously. Okay, and then also slightly about our t distribution. Okay, so for this part now, you need to know about the characteristic of binomial distributions, and of course you need to solve some problems related to the distribution. Okay, firstly, binomial distribution, again, you're doing for discrete random variables. Variables. And then, of course, in this case, you're going to have n independent experiments. N could be any numbers, okay, 1, 2, 3, 4, and so on. Okay, and of course, you have probability of success. Okay, probability of success. So, of course, here again, these are the important characteristics of your binomial distribution. The experiment will consist of the n trials, okay, could be 20, 30, 400, and so on, doesn't matter as long as they are discrete variables. And of course, in this case, you have success or failure, okay? So whether your experiment consists something that you call as success, you may say yes, you may say yes, no. So assume your yes is your success, and of course your no is your failure. But it all depends on what situation you're having. Okay, so of course these two are mutually exclusive events or mutually exclusive outcomes, alright? So if you still remember your Venn diagram, okay, if one is success, of course another is failure. You don't have in between. And of course the trials are independent. They are independent, you're talking about sampling with replacement. So you take one, take out one, and then you replace back into your experiment. And of course, you're having here your P here, and you also have your Q. Your P will refer to the probability of success, whereas your Q will refer to the probability of your failure. Failure, of course, the opposite of your success. And of course, please take note, since the P is referring to the probability of success and the Q is referring to the probability of failures, of course, total probability will always be 1. Of course, we are assuming that the probabilities remain constant for each trial. So let's take a look at one example here. This is also in your notes here. Now you're given here probability of a defective laptop. Now, it sounds like failure because the laptop is not functioning. But in this case, this is where you have your success events. Okay, it doesn't sound good because the laptop is not effective. Okay, which is defective, of course. but this is your success area. All right, and you're given here the probability is 0.05. This is of course your P, and of course sample of 10, random sample of 10. This is your N. Of course, if you need to write down proper way here, all right, meaning that you extract the information from the question. So please take note, yeah, the outcome that you have in the question is what you assume as success, right? So it doesn't matter whatever situation that you have, what you actually get in the question, that will be your success. So next. Okay, this is the formula for your binomial distribution, all right? This is again in your notes. Please take note. You have to know what's the N, the P, Q, X, C especially. Now this part here, your NCX here, please away from your calculator. Okay, please check which button in your calculator that has the NCX function. Alright, so the C here means combination. And of course, you also find it using this formula here. Okay, so NCX is also your N factorial. Okay? Your X divide by your X factorial. And of course, in bracket, your N minus X factorial. So you your P to the power of X, and so you have Q to the power of N minus X. Okay, so this is C, right? Basically, your NCX is also, you can also find using this. Okay? Your X here, X, X. Now this symbol here, this symbol, this upside down exclamation mark, this is your factorial, right? Your factorial symbol. Oops, okay, factorial symbol. Okay, you're going to look at it again after this, right? So after this, I will tell you more about factorial. So go back to your N, of course, again, number of trials. P, O is probability of your success. Your Q, probability of failure. This is, of course, 1 minus P. Your X here, your success, and of course, your N minus X refers to your failure. So please take note of these. This is where you need to memorize yourself because we are not giving you during your exam or your test. Please. Okay, let's take a look at how you want to find for the probability. Now, assuming you have here question A here, you are given your N equals X, X equals 3, P, you're given 0.03. You want to find for your probability when X equals 3. This is again follows formula. Check back your formula previously. P to the power of X, Q to the power of N minus X. Okay, you can substitute. Straight away you can substitute. Okay, straight away. And then of course, this again, please check with your calculator where you can find this button, the NCX. Right. Of course, finally you get 0.05, 0.0005. No. Okay, take note this part here. This is where you have your NCX here, or you may also say it is as N divide by your X factorial, your N minus X factorial. Same, of course. So your N here is 6. So in this case, you have your 6 factorial here, your x here, 3, so 3 factorial, and of course n minus x, that is 6 minus 3 factorial. You want to calculate for your factorial. This is it. This is your 6 factorial. So this is your 6 factorial. This is of course your 3 factorial. This it actually comes from your 6 minus 3 factorial. Meaning that 6 is your starting value here, and then you minus with the previous value. So 6 times 5 times 4 times 3 times 2 times 1. Okay, the same goes for 3 factorial here, 3 times 1 times 3 times 2 times 1. Again, this is 6 minus 3, of course 3 factorial again, 3 times 2 times 1. Okay, so up to you. So this option here, of course, this is where you are doing it manually. Of course, you can also use calculator to find the value straight away. Okay, so up to you which one you're more comfortable. Okay, second for B, again same thing except now you're having different n is 4, x is 2, and of course P is given to you 0.18. So substitute accordingly, then please always give in 4 decimal places for your final answer. Now this is it. This is where you have to define your N, P, Q, X on your own. So remember, these are the important things that you need to have for your binomial. Your N, X, P, and Q. So look back at your question here. A survey found that 1 out of 5, 1 out of 5, he or she has visited a doctor in any given month. 10 people. 10 people are selected at random, meaning that this is your sampling here. You take sample of 10 people. So this will give you an n. Find the probability that exactly 3. So it's your x here, exactly 3. 3 will have the last month. So you're given, you can know your n is 10. You can know your x is 3. You can know the probability 1 over 5. This is your success. Okay, this is your success. What is your success? Success that a person has visited a doctor in a given month. So this is the event of success that you have in this question here. So of course, 1 minus 1 over 5, this should be the probability of your failure. Okay, 4 over 5. So again, you substitute, okay, look back, you want to find probability that exactly 3. So your x equals 3. Okay, substitute into the formula, then you get probability when there are exactly 3 people visited a doctor, that is your 0.201. Okay, now this is from your exercise question. You can check the exercise in your notes. You have here a burglar system has 6 fail-safe components. Okay, fail-safe. Okay, it has fail-safe component. Okay, it doesn't mean that you have the word fail here means this is failure. No, this is again. Again mean your success events. What you have from the question is already given as success. So you have here your n components. Probability of each failing. Each failing, don't think this is your failure. This is actually the success. So you have here probability is 0.05. You want to find probabilities for the question A, B, and C. Okay, so write down this carefully. Write down all this information carefully. Okay, so you have your P 0.05. Okay, probability of each failing, but this is considered as your success. So again, P is referring to your probability of success. Q is the complement of your P, of course, and you also have the N. Okay, there are 6 components here. So you want to find exactly 3 will fail. Right, x equals 3. Please take note, this is can be found straight away from the calculator. If you don't want to use a calculator, you can use the manual calculation. It's going to take you a bit longer. So calculate, and of course you get the probability when there are six components which fail. And want to find less than 2, please take note. Now you're having here x less than 2. Be careful with the symbol. So it doesn't take 2, so it takes only from x is okay, because x equals 0 means no component is failing. X is 1 meaning that only one component is failing. Okay, so you substitute accordingly. You should get for the final. None will fail. None. X equals 0. You notice this is actually from here. Okay. So the same thing goes. You substitute accordingly. If you don't remember your formula, always refer back your notes. Okay, this is from your question 2 of your exercise 1. 30% here, a survey from the Teenage Research Organization found that 30% of teenage consumers receive spending money from part-time jobs. So this is your P. Problem of success. What is success events? This is the success events here. Okay, consumers receive money from part-time jobs. Okay, so this referred as your success event. And you have here 5 teenagers. It should be your N number of observations, number of users. Okay, probability at least 3 of them. At least means you're going to have 3 and 5. Right. So identify your P, of course, already given. Find for your Q, of course, 1 minus your P. So that is 0.7, and of course your N is 5. So you substitute accordingly, you should get this. Okay, next we look at another question. Given to you, research found that 40% of Americans, okay, so 40 Americans do not think that having a college education is important. Yeah, of course here random sample of 5 Americans straight away. This is your N. N equals 5 to find probabilities. So what you actually have here